Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our Math 6 content on for grade 6. All right, and we're going to move on to subtracting fractions. So with that, let's get started. I'm going to pick some examples from the textbook, and we're going to try some really simple examples at the beginning. All right, so I'm going to pick an example here. Let's try 7 over 9. Okay, minus 4 over 9. Okay, so as you can see here, the denominators are the same, which is 9. All you have to do is subtract the numerators. Okay, so I'm going to do 7 minus 4 over 9. Okay, and again, make sure you are writing going down the board as well, or on your paper. I'm going to subtract the two numbers on the top. So we're doing 7 minus 4, which is equal to 3. And the denominator does not change here. It's going to be the same. So it's going to be 9. Okay. So I see that I have 3 over 9. And again, remember, this is not my final answer. I have to make sure I'm reducing all the fractions. Okay. So what I'm going to do is divide it by 3 on both the top and the bottom. Okay. So 3 divided by 3 here, which is equal to 1. 9 divided by 3 is equal to 3. And this is my final answer. Again, I like to circle my final answer so the teacher can see that. Okay. If you stop and you put 3 over 9 as your final answer, it's not going to be wrong. Okay. But most teachers, again, will take off half a mark if you are not reducing it at the very end. Okay. Let's try one more example here. Okay. I'm going to take this off. All right. Let's try 5 over 8 minus 3 over 8. Okay, so one more time. Okay, I'm just looking at the bottom numbers, okay, which are the denominators. They both are 8. So we'll just put 8 on the bottom. Okay, and because the denominators are the same, we're just going to subtract the two top numbers for the numerators. I'm going to do 5 minus 3. Okay, and on the top, 5 minus 3 is equal to 2. Again, don't change the denominator. Okay, so my answer is 2 over 8. And right away, you should notice that I'm able to reduce the numbers. As you do more practice questions, you'll get used to it. Okay, however, if you see two even numbers on the top and the bottom, I know that I can divide them by 2. All right, when I'm reducing. So let's divide the top and bottom by 2. Okay, and I'm going to put equals. So 2 divided by 2, which is equal to 1. Okay, and on the bottom, it's 8 divided by 2, which is equal to 4. And that's my final answer, okay? It's 1 over 4. Okay, so make sure you are reducing all of your answers because some of these questions do seem a little simple, okay? But at the same time, I don't want the teacher taking off marks for that. Okay, are there any questions so far? Okay, good. So we're going to go to the next set of questions, okay? And this time, the denominator will not be the same. Okay, so I have to do just like one step in between. Okay, let's try this one. So this is 5 over 8 minus 1 over 2. Okay, so now before I do this question, okay, again, I can't just subtract the numerators and subtract the denominators and that's my answer. Okay, that's not how it works. I have to make sure the denominator is the same. Okay, so I noticed that there's an 8 here. I'm going to multiply the bottom by 4 as well as the top by 4 as well. Okay, so I have to make sure I'm doing whatever I do on the bottom, I should be doing on the top as well. So we're going to keep our first fraction the same. Okay, the numerator here is going to be 1 times 4, so 4, and the bottom is 2 times 4, which is equal to 8. Okay, so in the steps in between, I don't need to reduce anything here, okay? Because I just want the same denominator, which I notice is the case here. So I'm going to do 5 minus 4. Let's write it out here. Okay, and the bottom one is not 8 minus 8. It's just a common denominator, so it's equal to 8. Okay, and the denominators are the same. I'm doing 5 minus 4, which is 1. And the bottom number stays as 8. Okay, so this is my final answer actually. It's 1 over 8. Does everyone see how to do that? Okay, so in this case, I only had to multiply one of the fractions, okay, by 4 in this case in order to get a common denominator. Okay, there will also be cases where I need to multiply both of the fractions by each other in order to get that common denominator. Okay, but with that, let's try one more example. Okay, that's similar to this one. Okay, I want to make sure everyone understands the concept. Okay, so let's try this one. This is 2 over 5 minus 1 over 10. Okay. And again, I'm looking at my two denominators. I have 5 and 10. Okay, so there's no common denominator here. Okay, but I see that if I multiply the 5 by 2, on the bottom, that will give me 10. Okay, so because you are multiplying the denominator by 2, I have to multiply the numerator by 2 as well. Okay, does everyone see that? So on the top, it's going to be 2 times 2, so 4. All right, and the bottom is 5 times 2, which is equal to 10. Okay, so the first fraction, the equivalent to that, can be 4 over 10, okay? And I didn't do anything to my second fraction, so I'm going to keep that the same, 1 over 10. And now I notice the denominators are the same, so I can subtract the numerators. So I'm doing 4 minus 1 over 10, okay? 4 minus 1 is equal to 3. Okay, and my answer is 3 over 10. Okay, now again, when you get your final answer, always check that you can reduce it. Because 3 is a prime number, I can't reduce it anymore. So that's a good way to check and make sure that is your final answer. Okay, so this was basically just the fractions where you are changing one of the fractions here to get the common denominator. Okay, we're gonna move to the next set of questions here. Okay, and I'm going to take this off. We're going to try this example, okay, so everyone can see what I mean when I say that you have to multiply the numbers by each other. Okay, so this is 3 over 4 minus 2 over 3. Okay, and you notice it's actually very similar to when you're doing adding fractions. Okay, both of the denominators are different here. Okay, so I need to multiply them by each other. This is 4 and 3, okay? I'm going to multiply the 4 by 3. So I'll put times 3 on the top and the bottom, okay? And then the 3, I'm going to multiply it by 4. Again, on the top and the bottom, okay? So it will look like this. Alright, so on the top, it's going to be 3 times 3, okay? So 9. And on the bottom, I'm doing 4 times 3, which is 12. Okay, minus, let's go to the second fraction. We're doing 2 times 4, which is 8. And I can see that the bottom is the same thing, 3 times 4, so 12. Okay, so I'm looking at basically these two fractions here. Okay, the denominators are the same, and now I can subtract the numerators. So you can see that I'm actually writing out all of the steps here. Keep the denominator the same, okay? When you get really good at it, you can skip a couple of the steps, okay? But I would still show maybe one step in between so the teacher can see where your answer is coming from, okay? And you should always just check with your teacher, okay, which steps you need to show and which steps you can actually skip, okay? Just so some teachers are really picky, they want to see all your steps, okay? And you don't want them to take off any marks for that. Okay, so let's get back to this example here. So we're going to do 9 minus 8, which is equal to 1. All right, and then the bottom is going to be 12. And this is my final answer. Okay, so my final answer looks like it's 1 over 12. Okay, does everyone see how to do that? Are there any questions? Okay, good. And so again, you're just multiplying these numbers by each other. Let's try one last example, which is going to be similar to this one. Okay, so let me just take that off. Okay, so in this example, let's try 2 over 3. Okay, minus 1 over 2. Okay, so let me move it up. So again, we're looking at the denominators. Okay, I have 3 and 2. There's no common denominator here. Okay, I can't even multiply one of the fractions to get a common denominator. And the reason for this is that 3 and 2 are both prime numbers. So again, a prime number is basically a number that can only divide by 1 and then you can divide it by itself. Okay, so that's the definition of a prime number. All the other numbers that have more than 2 factors here are basically called composite numbers. All right, so if we're looking at this, we're going to multiply the 3 and 2 by each other. I'm going to multiply the 3 by 2. Okay, like that. I'm going to multiply the 2 by 3 on the top and the bottom. Okay, so if you look at the first fraction, we're doing 2 times 2, 4. And on the bottom, it's 3 times 2, so 6. That's the first fraction. I'm going to move to the second fraction. I'm doing 1 times 3, so it's 3. And 2 times 3 here is equal to 6. So one more time, I notice the denominators are the same here. I'm going to subtract the numerators. Okay, so I wrote down 4 minus 3. And the bottom stays as 6. Okay? And when you're doing 4 minus 3 here, it's equal to 1. And the denominator is 6. So this is my final answer. Okay, I'm getting 1 over 6. Alright? So again, make sure you're always just checking the denominators. I need to have a common denominator every time I'm subtracting fractions or adding fractions. This is basically the method by which you should be doing it. Okay, I always show what number I'm multiplying by for each of the fractions. Okay, so the teacher can actually see that you are doing the right method, just in case you don't get this as the final answer. All right. So that brings this video to an end. Today we covered Math 6, subtracting fractions. And if you did like the content, please make sure you are subscribing to the channel and click on the like button below. And I will see everyone next time. Thanks. Bye.